All right, you are assigned number 17. I'm going to do number 16. And I would love to tell you that 16 is much harder than 17, but it's not. They're harder. So they're harder than the first type. You have to think about them more. And I'm going to try to go through this a little faster, but still give you insight into how you do these, how you do this. All right, so let's go. I'm doing number 16. Like before, I write down all the rates. I forgot the 150 kilometers, but it's not quite clear what the 150 is right away. So let's hold off on the 150. I see the 35 first, so that's a rate. And I call this DRA DT. I reserve the right to change my mind later. But it's the rate at which ship A is sailing east. And 25 kilometers per hour is the rate at which the ship B is sailing north. And that's, I call it DRB DT. My husband says that math people always are subscripting stuff. We should just call it what it is because he's a programmer. That being said, I did this and I changed my mind later. They give me some information 4 hours after the ship starts. That's how I interpreted this 4 o'clock p.m. This is reminiscent of what you did in MA 103. You had a lot of time given, but you had to translate that back into times in hours. So if noon is the start of this scenario, then 4 hours later is that freeze frame moment in time. I'm not quite sure yet how to piece this together like the other problem. It's because this is much more complicated. I'm going to keep that 150. It's some kind of freeze frame moment in time, but I'm not quite sure what. It's the start. It's t equals 0. All right, so now I'm going to start to draw a picture. Ship A is going east. Ship B is going north. They didn't say this, but at noon, they should have said ship A is directly 150 kilometers west of ship B. I believe that's what they meant. So right here at noon, it's 150 kilometers. That's where the 150 comes in. And the distance between the ships is that teal line right here. And what I didn't draw later, which I should have, I'm going to do it right now. What's happening is the other ship B is going north and this ship is going up. So this distance is actually increasing as it goes as ship A goes to the right. And what's going to happen is eventually they're going to cross. That's actually not going to happen in this scenario. I'm going to show you why as we evolve this picture. But imagine this teal line getting steeper and steeper as ship A moves east and ship B moves north. Billy Bolt told me that he hates these problems. I kind of do too. I gotta agree with him. I think of them as puzzles. All right, so here is where I changed my mind. And I changed my mind because I'm thinking of Pythagorean's theorem that says a squared plus b squared is c squared. I already have it in my mind because I see a right triangle here. So it makes me think of this not just because I'm insane, but because I do a lot of these kind of problems. So I'm thinking about Pythagorean's theorem. So I'm going to call A of t the distance of the ship A at t hours after my start point, after this red dot. And I should have said that. Ship B is the distance of ship B at t hours after the start point, which is going to be at this intersection I've drawn and up. I put this off to the side. Your cadet eyes are better than my eyes, but you probably can't see it like I can. I can't see it as well, but you probably can see this. So if I look at the question, how fast is the distance between the ships changing at 4 p.m.? That is a rate that they're asking for. And if I want to put this in terms of my picture, C, they're looking for dc dt. They want to know how fast is that distance increasing. They didn't say that, but I drew a little picture to show you that that line is going to get steeper and longer, that teal line, as the ships move. All right, so that's pretty hard and complicated. I hope I explained that well. So here's what I'm looking for. What's my list of formulas? Well, I really only have Pythagorean's theorem. So a squared plus b squared is c squared. What I call dra dt is really dA dt. And what I call dB dt, that's really, drB dt, that's really dB dt. And I changed my mind as I went through this problem because initially I was thinking maybe this has something to do with distance equals rate times time. It doesn't. It has all to do with the triangle. So as I'm unfolding things, I decided to call my leg A, the other leg B, and the hypotenuse C, and so I changed my mind of what I was going to call these rates. 150 kilometers is A, not always, but A at time equals 0, and I'm going to use it. So how am I going to use this? Well, that's 7. I have all my assembled stuff, and I'm going to start piecing it together. First of all, if I take the derivative of a squared plus b squared equals c squared from left to right using implicit differentiation, I get 2a dA dt plus 2b, I'm using power rule, dB dt, equals 2c dC dt. That's 2a times 35 plus 2b times 25 equals 2c times dC dt. And I got a lot of letters still left in there. If you remember the previous problem, I was able to knock it out at this stage because I just had one letter. But I have a whole bunch of letters here to keep figuring out. So at 4 hours, I do use distance equals rate times time. I lied. But B is the rate times time, and 25 is my rate, and 4 is my time. And so I get 100 kilometers at 4 hours. A is the rate times time for the distance that I've covered. So here it's tricky. It's how much distance I've covered to the right. So if I look at my triangle, I did this funky thing. Let me see if I can do it again on my picture. So, let's see. Shapes. So let me deface my shape here so you can see it. I'm going to go over here. So as this is moving along, I'm really covering distance from here to here. So I have to, the distance here is going to, if the total is 150, my distance down here, so this is my this is my line that's changed. If I look at the distance below here, right down here, and let me make that thick for you. So that distance that I've just drawn down below, I don't know why it's gray, but this distance right down here, it's actually 150 minus whatever I've covered. So the distance that has been run already is 140 kilometers. So I have to take 150 and subtract 140, because that's the distance I've covered, to get that gray distance. So 150 is my total distance at time 0. By 4 hours, I've covered already 140. Maybe the better picture would have been to see distance covered. That gives me that little gray bar that's up here. That gives me this gray distance, because the green piece over here is 140. So I subtract to get the gray piece, and that's 10 kilometers at this particular time for the triangle I'm looking at. So if I plug into Pythagorean's theorem, which is C is equal to the square root of a squared plus b squared, I get C is equal to approximately 100.499. That's really confusing, and I hope that I explained that decently enough. If not, send me a text or send me an email. So if I plug now everything in, at A equals 10 at the freeze frame moment, B equals 100 at the freeze frame moment, and C is 100.499 at the freeze frame moment, now I'm left with only dC dt. And if I just do the division, the arithmetic in the division, I get dC dt is increasing at 56.72 kilometers per hour. So that line is stretching, that hypotenuse is stretching up at a rate of 56.72 kilometers per hour. I went back and looked at your problem, and I wondered if it would be the same. It is. You have one car is moving south, so you're going to have something like this. You can call it car A if you want to. And then car B is traveling west, so you're going to have another car B that's going this way. And they started at the same point, so that's a little bit different than mine. They made this weird thing about the west. So it's a little bit easier than mine. So this is the time equals 0, is they started at the same point. One is going south, one is going west, and they give you the rates, but you still have this triangle, and you still have this freeze frame moment at 2 hours later. And so you still have some of those things that you are looking at. And you're also looking at the distance between the two cars, which you're looking at the hypotenuse. So have fun with this one. I hope you do okay with it. You do have the answer, and you can get help from me if you need.